Calculus, find where the graph of this function is concave down. So we have this problem here. Let f be the function given by f of x equals 2x e to the x. The graph of f is concave down when, and we have 5 different answer choices. Well, to find the relationship between f and downward concavity, I have my students look at this chart, the f prime, and f double prime chart. And this is a quite helpful chart. So we put plus minus, so we're doing the f row, and we have concave up, concave down. And then the f prime row, we put our plus or minus here, and then the increasing, decreasing. And then in the f double prime row, we put plus or minus right here. So our strategy is going to be to look at our second derivative of this function right here, and specifically where that value of that second derivative function is negative, because where that value of the function is negative, we're going to have f being concave down. So we're going to say f prime of x is equal to, what we have here is a product of two functions. We have a product of 2x and e to the x. And so as a graphic organizing technique, I have my students draw a little box like this, and then we put 2x and 2. One of those functions, product of functions, can be 2x. And then we have e to the x, and the derivative of the e to the x is also e to the x power. And so what we can do is use these values here. And so f prime of x is equal to 2x times e to the x plus we have 2 e to the x power. And then simplifying, f prime of x is equal to our common factor, which is going to be 2 e to the x. And what do we multiply there? Here, x plus 1. Okay, so that's going to be our f prime of x. But we're going to look for our second derivative, as we have in this chart here. And to do this, I'm going to change our color code here. We're going to go to f double prime of x is equal to, now we're going to do the product of these two functions here. I'm going to make our little convenient box at the right. So we have 2e to the x. And what is the first derivative of 2e to the x? It's going to be the same, 2e to the x power. And then we have our, as a product of two functions, we're going to have x plus 1 here, and then just 1 over here. So we're going to have 2e to the x times 1, so 2e to the x times 1, plus we have 2e to the x times quantity x plus 1. And now, with our common factor here, f double prime of x is equal to 2e to the x. And what do we multiply by 2e to the x to get 2e to the x? It's going to be 1. And what do we multiply by 2e to the x times quantity x plus 1 to get this, it's going to be x plus 1. And so, kind of finalizing this, f double prime of x is equal to 2 e to the x, and we're going to have 1 plus x plus 1 is going to be x plus 2. Now what we're going to do is set this second derivative equal to 0 to evaluate. So we put 0 equals 2 e to the x times quantity x plus 2. And we should understand that this 2e to the x is always going to be positive for any real number, just basic exponential function logic. So we're going to have 0 equals x plus 2. And now I'm going to put a number line in place here. We're going to find our critical number by solving for x. X is going to be equal to negative 2. So we put over here negative 2. And then above the line we put f double prime of x. And then f of x below. And so now, with this equation here, if we let x equal less than negative 2, we're going to have, let's say it's negative 3, we'd have negative 3 plus 2. We'd have f double prime of x being negative, and if x is greater than 2, say 0, we're going to have positive. So we are going to be just using our original chart here in the upper right, where f double prime of x is negative, we have concave down, and where f double prime of x is positive, we have concave up. So our answer is going to be concave down on negative infinity to negative 2, because f double prime of x is negative or less than 0. And so our correct answer is going to be A. And just for the sake of corroboration, I previously graphed this in the calculator, and we can see this function here, and we can see the function here. It looks like it's concave down, all the way to 2, x equals 2, where our point of inflection is, at which point the graph starts goes to concave up. So that's it. I hope this has been helpful to you. Good luck, and thanks for viewing.